Hey friends, hope you're doing well. Today I'd like to show you how you can use stacking ensemble in machine learning to get better results. So let me show you how that works. At first, let's import the libraries we need. In this case, I'm referring to NumPy, which is a standard library for numerical Python, as well as the scikit-learn library, which is great to use any kind of, let's say, base machine learning algorithms as well as ensemble methods when we do not deal with neural networks. Therefore, we would use TensorFlow or PyTorch probably. But for those other machine learning libraries, scikit-learn is really the way to go. It's really an awesome library and provides so many features. So I encourage you, just use it, try it out. You can see that we use make classification to get some dummy data. Of course, you could also use your own data set for that if you want to apply this later on your own data. And we use cross-validation in this case, so we do not need to use train test split. So we use our whole data set. And then we import specific machine learning algorithms like logistic regression, k-nearest neighbors, and so on. It's up to you what kind of machine learning algorithms you want to try out for that. And then we just instantiate here a few methods like get dataset, or we create the methods. It's not a class, so we do not really instantiate it, but we create the methods here, and we say xy, make classification, and then we return those values. So as I said, it's just to get some dummy data. Of course, if you have your own data, feel free to use this later on. Then we create here our get stacking, so the stacking classifier, simply by using some weak learners here, like logistic regression, k-nearest neighbors, decision tree, and so on. And then we create our stacking classifier, which in this case is the level 1 here, which in our case is logistic regression. If you have a regression problem, you probably want to use as level 1, for instance, linear regression. It's often used for that. So then we create our stacking classifier using stacking classifier class from scikit-learn, and then we return the model. The idea behind stacking classification here as an ensemble method is the following. We use the results of the weak learners, so these classifiers here, and then we let the level 1, in this case our final estimator, figuring out what is the best way to combine the predictions of the weak learners to get a better result for the final estimation. That's the idea. And if I scroll down a little bit, then you can see here we use the get models function, which means that we simply create a dictionary with all our basic machine learning algorithms here, and then finally our stacking here, which is calling here our function get stacking, just to get the stacking classifier. And then we return all the models. The reason for doing this here is that I want to compare the results of the base, in this case machine learning algorithms, and of course my stacking, and show you that the stacking in this case is really better, and also the reason why stacking is often used, or at least has often been used in the past, in Kaggle competitions. So then we create an evaluation function here, which is evaluate model, which uses then the repeated stratified k-fold. In this case, you can specify the splits as also the repeats. Of course, the higher those values, probably the longer the whole algorithms runs. And then, of course, we return the scores here. So then we simply call the methods here. So we get our data, we get our models. And then here, in this case, we simply then loop through the models, in this case, and evaluate the results. And then finally, of course, we also want to print the results here. And also then I want to show you, so visual, as humans, we are visual people, right? So we want to see the results also as an image, and using the box plot from the PLT package, so pyplot, or actually the matplotlib package. So long story short, you can see if I scroll down a little bit, this is the result we get. So we print out here the mean of the algorithms as well as the standard deviation here. And of course, the higher the mean result, the better the accuracy in this case, and also the lower the standard deviation, the better, right? Because what we want is we want a very high accuracy, but also a very low standard deviation regarding the results, considering our 10-fold cross-validation. And if we take a closer look at the results in the image, we can clearly see that the stacking classifier here has a very, very high accuracy. So with, in this case, 96% almost, but also at the same time, a very, very low standard deviation, as you can see here. And if you compare this one here, the stacking, to all the other machine learning models, you can clearly see that the stacking is the best result because it has a very high accuracy, at the same time, a very low standard deviation. That's why it's so small compared to the other ones here, for instance. Okay, and that's basically it. So this is actually a way how you can implement stacking for your machine learning problems. And of course, as I said, you can use this for classification as well as for regression problems. You just make sure that you use the right final estimate in this case. So hopefully you enjoyed it. If so, please give this video a like, also share it, and please show also your gratitude, let's call it this way, and subscribe to the channel to see more. If you got questions, also feel free to ask, and I'm trying my best to answer them. Otherwise, thanks for watching, take care, and see you in the next video. Until then, best guys.